So welcome to chapter 3. So we're gonna look at modern CPU architecture and assembly language programming. So in this chapter, we will be focusing more on real operating system and real CPU. So until now, we were looking at different types of theory and working of toy circuits and stuff like that. So this is more realistic focus on the actual operating system and system in general. So this is the agenda of this particular chapter. We know a lot about the working of computer. We looked at the internal components and stuff like that. Now we're going to focus on one operating system, which is Windows 10 in this case. So we won't go into deep down of the Windows 10 operating system or anything deep, but we will get to understand a little more depth than a typical layman's perspective in this chapter. We will focus on the Intel x86 CPU, the CPU architecture, so which is common for Intel as well as AMD CPUs. The PC we built is the Intel x86 architecture CPU. We're gonna look at the internal structure of it, and we're gonna write some computer programs, assembly language based computer programs. And we're gonna look at the assembly language itself, which is the programming language we use for CPUs. And these are all related concepts. We will look at CPU registers, computer memory, etc. We don't do in-depth programming. So this chapter is not really hardcore programming, computer programming course or chapter in general, but we will see a lot of glimpse of concepts of computer programming. We won't see a full-fledged computer programming. And we will see some overview of some of the devices on the way. Yeah, so that's the agenda. So we need some tools for the demos of this particular chapter. We will be doing most of the demo in something called Visual Studio. So we'll be installing Visual Studio to start with. We can use any version of Visual Studio for this particular exercise. Visual Studio 2019 is the latest version. And we will be using Visual Studio 2019 for our purpose, and we will be using Community Edition, which is a free software. So if you are on any other system other than Windows, for example, Linux or Mac, respective instructions can be found in the documentations of this particular product. For example, Mac, it is Xcode, so it is similar to Visual Studio, and if it is Linux, it is going to be GCC. But definitely the UI interface, which I'm going to explain, is going to be different for Mac and GCC. Again, one more thing I would like to mention here is I'm going to use Visual Studio 2019. By the time you see this presentation, there could be a recent version of Visual Studio, or you can use an older version of Visual Studio. But one other thing is that whatever we are going to see in this presentation is at least 30 years old. Irrespective of the tools and the operating system you use, all the features we're gonna see, like the memory, disassembly, everything will be there. All you need to do is to find out, but it'll be different buttons and different menu options. But concept and the options will be there for sure. That is one thing I would like to mention before we proceed. So before we start, let's get some installation things out of our way so that it'll be smooth. So what we're gonna do is we're gonna download and install Visual Studio 2019. In fact, the Visual Studio 2019 is already installed in this computer right now. What I'm going to do is just start the installation just to show you how it's going to look, the installation part. The best way to download Visual Studio is just go and search in Google, so you will get the latest link. I'm going to the download of Visual Studio 2019. So this is the location where you can download the Visual Studio. So you can go with the free download. If you're on Mac, you can use Visual Studio for Mac as well, but I have not done this demos in Visual Studio for Mac, so I'm not sure at this point. That is one option worth exploring if you don't have Xcode in the Mac. I'm gonna click on free download. So it has started here. I'm going to click on here I'm going to click yes. I'm going to do continue. So this is going to take some time. I will pause the video. So I have already Visual Studio installed. That's why it's giving me an update option rather than install option. In your case, it will be install option and you can go ahead with installation. So I'm going to cancel this because it's already installed and I don't want to install it again or update it at the moment. So I'm going to click cancel. When you start the installer like we did, you will see this many components. So these are the different libraries and components this installer can install. Out of which, make sure that you have selected C++ in desktop development. So this is the option. So basically we need to have C++ compiler and related modules for our demos. So I have already installed. That's why it is having the blue check here. It is installed. So I'm going to close this because I already have it. In your case, you have to check this tick mark and install while downloading or any of the option which is convenient to you. So I'm going to close this as well. So we have installed Visual Studio, but we have not explained what it is. So why we have installed. So Visual Studio is a Swiss Army knife for all development purpose, software development purpose in Microsoft platform. Right now it has started code development for other platform as well, like Linux and Mac, etc. So a lot of cross-platform development. But it's a tool, it's a very heavy tool to develop software, to create software. Yeah. So different programming language it supports, different development tools it supports. So we are not going to do any detailed analysis of Visual Studio. We are just going to look at a couple of things, very few things in fact, not even tip of the iceberg. And I will explain each and everything as and when I use it, rather than giving a huge overview about a very big tool right now. So there is also a similar naming tool called Visual Studio Code. So Visual Studio and Visual Studio Code. They are similar tools but for different purposes. In our case, we need Visual Studio, and in our case, Visual Studio Code doesn't work. If you attempted to install Visual Studio Code, because it's very small and concise, it doesn't work because it doesn't have the disassembly feature of Visual Studio, which we're going to look today. Let me explain some of the jargons which I'm going to use throughout this presentation. Process, program, application, code, software. All this is referring to code or instructions to the CPU or the software in general. Yeah, software in general. These are the different terms I'll be using. They are slightly different entities, but in our context, it's software part. Now, programming, coding, computer programming, software development, all this is the creation of this first entity. All this is referring to creation of this first entity, which is software. System, kernel, operating system is OS is operating system itself. All this is referring to the Windows core operating system in this chapter perspective. There are other operating systems as well, but we will be focusing on Windows for this purpose. CPU, hardware, processor, all is the chip we have seen in the chapter 1, the microchip of AMD. So that chip we are referring to CPU. So when I say hardware, the CPU plus rest of things, but mainly I'll be referring to the CPU itself, not anything else. File, secondary storage, file in disk, disk storage. These are the names I'll be using to name the secondary storage or secondary memory. Whenever I say memory, it is the primary memory, the RAM, the random access memory. When I refer to the secondary storage, these are the names I'll be using. Now, RAM, memory, computer memory, program memory, process memory, all refers to the random access memory or the chip we have seen. Remember that long chip with a lot of black ICs in it? So
4 chips.
4 chips, that's right. Yes. So that is what I'll be referring to. Opcode instructions, CPU commands, operations, opcode, operation code, everything is a single instruction to the CPU. So basically, this builds this. A computer program is nothing but a series of opcode or operating instructions, operations. Yeah. Whenever I refer to one of those operations to the CPU, I'll be referring to one of these words. So memory address. So these are the addresses of different CPU instruction and memory inside the computer memory. There is this concept called addressing in memory. We will see it. We will be keeping a lot of data inside the memory. So we need to have different addresses for that data to access the data. I'll be explaining this. This may not be very clear to you right now. When I show you the memory inside the Visual Studio, I will give you more input on this particular piece. But memory address and address, it's one and the same thing. It's going to be a 32-bit value, and that is exactly same as memory address and address. Yeah, that's the only thing you need to remember right now. Any questions? All right.